Hello and welcome to my video on going backwards. So hopefully you watched the naming compounds video first. This is going to be talking about if you were given a name, then you need to give me the chemical formula, the process to kind of do that. This is probably going to be more useful in real life anyway. So if you have a name like potassium oxide, how do you know what formula to write? Does it have subscripts? What are the subscripts? If you have sulfur dioxide, what do you write? So the first thing you need to do, like we were doing before, is decide if it's ionic or if it's covalent. The same way that we were doing before is to talk about if it's metal or non-metal, then that is going to be an ionic if it has metal. Non-metal and non-metal is covalent, and we talked about in the other video using the staircase. So this is all metal, this is all non-metal, except for hydrogen is a non-metal. The other way you can do this when you have a name is to look at the prefixes, because an ionic compound is never going to have any prefixes. So you'll notice we have nothing in front of potassium, nothing in front of oxide. There's no prefixes there. So this is going to be an ionic compound. I know that because there's no prefixes and because potassium is a metal. So this is an ionic compound. So I'm going to write that down so I can remember it. Sulfur dioxide. So if we look down here, we have non-metal and non-metal and then prefixes. I have no prefix in front of sulfur, but I do have a prefix in front of dioxide, or in front of oxide. It's di. So that means this has to be a covalent compound. And we can check it by saying, okay, here's sulfur and here's oxygen, both nonmetals. So yes, it's covalent. So I'm going to write that down too. So we're going to go through the process of figuring out how we can get the formula from this name. We're going to do the covalent one first. So we're going to do sulfur dioxide. So the first thing I need to do is write down my first element, which is S, sulfur. Sulfur is S, and I get that from the periodic table. And I have no prefix in front of sulfur. And remember, you have mono on our second element if there's one, but if you have your first element and you only have one of those, you don't have to have a prefix. So if I have no prefix in front of sulfur, then it's just going to assume one. I can write that one, or I can leave it off. That means the same thing. My next element is oxygen, because oxide is oxygen, so I'm going to write oxygen. And then I need to look at my prefix in order to get my subscript. So di is my prefix, and di means 2, so SO2. So that's the chemical formula for sulfur dioxide, SO2. And that's pretty easy when you just use the prefixes to figure it out. No prefix, so I know I had 1. Di means 2, so I know I had 2. So covalent's the easiest one to do. When we go over here to ionic, because this one was an ionic compound, we don't have any prefixes because it's ionic. And so that means if I went by that, then I would just write down K and O, and then that would be the answer. But that's not correct. That's not what's actually going to form in nature. So we have to kind of go an extra step in order to figure out the subscripts since we have no prefixes. So that means that I need to write down, I need to use my charges, and I need to do the crisscross method. So as a reminder for the crisscross method, when you're trying to figure out the subscripts of an ionic compound, you can use this method called the crisscross method. Here's the basis behind it. If I have an element with a +2 charge and an element with a -1 charge, and I try to put them together, the charge of that compound is going to end up being a +1. They don't want that. They want to have a neutral charge. That's the whole point of bonding. They're going to donate their electrons so they can have a full valence shell, but then also so that they can have a neutral charge. So this compound would not work in real life. However, if I added another chlorine, now I have this barium with a 2+ charge, a chlorine and another chlorine, and now I add up my charges. I have a +2 and a -1 and a -1. That's 0. So that's a neutral charge. And that's what we want. So that's why the formula for this is BaCl2. However, this is a lot of thinking to go through, which is why we have the crisscross method, which is supposed to be the fast version, the trick version of that. So if you write down the charges and then you crisscross them and the charges become the subscripts, then you end up with Ba1Cl2, and you don't have to write the 1, so it's BaCl2. So hopefully that's a good review on crisscross method. I'm going to use it over here to get my subscripts. So you can use the ion charge wheel that we've been doing to figure out your charge. So here's potassium, and I could do that. Or I can look on the back of my periodic table, and potassium is in this column, which means it has a +1 charge. Oxygen, I know, is in this column, So it's going to have a -2 charge. So I'm going to write that down. So potassium with a +1 and oxygen with a -2. And if I do my crisscross method, then I will end up with the answer K2O1. And I don't have to write ones, so the final answer would be K2O. So I would have no way of knowing that I had 2 potassiums in this compound based on looking at the name. But I do, which is why you have to do the crisscross. Let's do another covalent just for practice. So I have dihydrogen monosulfide. First thing I'm going to do is look at hydrogen, so that's my first element, so I'm going to write that down. And I have a prefix, wonderful. So di, and di means 2, so H2. And then I see sulfide, which is sulfur, so I write S. And then my prefix is mono, and mono means 1. And I don't have to write the ones, so my final answer would be H2S. And that would be the chemical formula for dihydrogen monosulfide. I have one more ionic for us to do, aluminum sulfide. And once again, no prefixes because it's ionic. And so I'm going to have to do the crisscross method in order to get the correct subscripts. So I write down Al, and I write down S, and Al is here in my 3rd column, S is in my 6th column. So when I look on the back here, here's my 3rd column, +3 charge. And the 6th column has a -2 charge. And now I can do my crisscross method to get the final answer. The 3 moves down here, the 2 moves down here. You don't have to put the positive and the negative because the subscript is telling you the number of atoms, and you can't have a negative number of atoms. So my final answer is Al2O3. And once again, no way of knowing that without doing this method. You can't get it from the name. So the big idea of what I'm saying today is, if you have prefixes in a name, use them. So if you see anything with a prefix, like this one over here, just use them. No crisscross. Don't bother crisscrossing. You can't do it. Just use the prefixes. They're like giving you the answer. If you don't have prefixes, you have to crisscross. That's the big idea. So if you look up here and you know this is an ionic compound and you know there's no prefixes, that's when you have to do the crisscross method. So hopefully that will help you to figure out how to do this going backwards thing on the test that we have coming up. Let me know if you have any questions, and have a wonderful, beautiful day. Goodbye.